Welcome back to Old Guy Physics, and this is the last of the projectile problems, and the ones that I think that many of the students thought were really difficult. They don't have to be. And so let's go back over this again. Let's go through the steps and let's see how this one's a little different than the ones that we had worked before. First of all, if we look at the problem, we can see that the cannon has a velocity and it has an angle, 18 meters per second at a 60. So automatically we know that we've got to solve for v sub x and we're going to solve for v sub y. We'll do that in just a second. We also know that there's going to be a little guy math done in step 2 where the ball goes up in the air, but this time instead of it coming all the way back down to the ground, it's going to land on top of that building. And so it doesn't get to fall the full length or distance down, so the time down will be different than the time up, and that's important. But let's work through it and let's see if we can find out the simple things that we need to find out. So first of all, we've got 18 here and an angle of 60, and like we said in the previous video, we're going to run this polar rectangular. So we've got 18 at a 60, and we're going to go polar rectangular. And it says that v sub x is 9 meters per second, right there. And v sub y is 15.59 meters per second. So that's everything we need to do for step 1. Then we take this velocity in the vertical direction and we give it to the little guy. And so he's got 15.59 here, so we need a time and a distance up. And then we're going to need a distance so that we can solve for a time down. And so we should remember that we have v sub y is equal to 10t and d sub y is equal to 5t squared, which again are the free fall formulas. We're going to plug 15.59 into the first equation, which, and whenever you divide by 10, that's the same as shifting the decimal point 1 to the left. So the time's going to be 1.56 seconds in the up direction. So next thing we need to solve for is what was the distance it traveled up in that 1.56 seconds. So 1.56 squared times 5 is 12.17. So that's 12.17. Now, if you look at this problem, you can see that if the building wasn't in the way, it would have fallen 12.17 meters back to the ground. But because the building is 6 meters tall, it's only going to fall for a portion of that 12.17. And the way we figure that out is we subtract 6 from the 12.17, and we find out that 6.17 meters is the distance it's going to fall on that back side. Now, how much time does it take to fall 6.17? We plug that into the distance equation, and 6.17 divided by 5 equals, and take the square root, and it says that the time is going to be 1.11 seconds. So it went up for 1.56, but it's going to fall for 1.11. So if they ask you what was the total time in the air, you would add those two values together. So 1.11 plus 1.56 is 2.67. So the total time is 2.67 seconds. Now, what we learned about this projectile motion is that the horizontal speed is a constant. So it's constantly moving from left to right at 9 meters per second, and it's doing that for 2.67 seconds. So the formula that we used in step number 3 is d sub x is equal to v sub x times t, and v sub x is 9, and the time is 2.67 So 9 times 2.67 equals 24.03 meters. So that when that cannonball lands on top of the building, it will have traveled horizontally 24.03 meters. We've got highest point, we've got total time in the air. I think we've pretty much solved for the whole thing. And you can see that if it starts low and it ends up high, the distance it falls on the back side is going to be shorter, so it's going to be a shorter time. On the other hand, if we had a problem that looked a little bit like this, where the cannon was on a hill, like this, and the cannonball went up in the air and came down, and let's say that the hill was 6 meters tall. Well then, if we do a little dotted line out here, the little guy math starts here, he goes up in the air and comes down. Well, the front side is shorter now because it only went up in the air from on top of the hill, and then it has to fall the distance that it went up plus the height of the hill, which was 6 meters. So when that dotted line right there, that says that this is 6 meters, and then we simply have to solve for d sub y over here on the left-hand side. But it works, the steps are the same. It's just important for you to see in this problem, the front side is longer and the back side is shorter. In this problem, the front side is shorter and the back side is longer. And so the time would be shorter here and the time would be longer for the longer fall. Now, if you have any questions about this, come and see me. But I think that this should help as a review for the test that we're having on Tuesday. Thanks for watching. Have a blessed day.